Hello again. In this video, we are going to look at the problems related to solving for one variable explicitly. And in this case, in all of the problems, we're going to be trying to solve for Z2, so isolating it on one side. And here again, Z2 is simply a symbol. The subscript 2, we sometimes use that in chemistry if we have two different things of the same property, like the radius of one atom and the radius of a second atom. We might use R1 and R2 to represent the two different atoms. So the 2 isn't a mathematical 2 as much as it's, we could call it RA and RB for atom A and atom B as well. So it's just a marker. So part of this is just getting familiar with symbols and symbol notations and how to think about them. So in all of these, our task is to get an equation that simply says Z2 is equal to some other collection of constants. We want to isolate that Z2. Again, lots of different ways to think about this. If you know other ways or think about it differently, I'm not saying this is the only way. I am showing the way that has been useful for me professionally and how teaching it to other students has helped them catch on. So one of the things that I like to do in this situation, and I've seen a lot of students do this, is to explicitly write the Z2 so that it cancels this side, but by putting it up there, we also have to multiply the other side by Z2. So multiplying the other side by Z2, now we have it in the numerator over there. So if we were to rewrite this, we see that by multiplying this side by Z2, it clears out of the denominator. So this side is going to simplify to just 6a. And this side now has Z2 in the numerator. So we would have Z2 times 4 times Y1 over 9 is equal to 6a. So we're one step closer to having our simplification. But at this point, we'd like to still isolate the Z2. So we need to get rid of the 9, the 4, and the Y. So one way we can do that is by multiplying both sides by 9. So we'll multiply both sides by 9, and we'll divide both sides by 4 times Y1. Divide both sides by 4 times Y1. And again, whatever we do to one side of the equation, we have to do to the other side of the equation. We talked about that in the video. If I say 8 is equal to 4 times 2, if I say 8 is equal to 4 times 2, if I only multiply one side by 3, I no longer have an equality. Right? This would be 24 is equal to 8, and that's nonsense. So we'd have to say 4 times 2 times 3. Now we're back to having an equality. No longer 8, we have changed it, but we at least maintain the equality. So now we can simplify all of the 4s, the Ys, the 9s cancel, and this side just becomes Z2 is equal to 6 times A times 9 over 4Y1. So this would be the simplification of that problem. And now if we knew what A was and what Y was numerically, we could take those values, multiply by 6, multiply by 9, divide by 4, divide by whatever Y was, and we'd get a number for Z. And if we had units, we've seen that we would be able to manipulate the units and also determine the units on Z. Equally important as manipulating the numbers. So for the next one down, if we wanted to isolate Z2, same process, multiply both sides by Z2, so we end up with Z2 X1 Y1 over Z1 is equal to X2 Y2. Numerator and denominator would have canceled. And then we would want to multiply by Z1 and divide by X1 Y1. So when we do that, we end up with Z2 is equal to X2 Y2. Z1 comes up, we'd multiply both sides by Z1, and we would divide both sides by X1 over Y1. And in this case, we wouldn't be able to cancel X2 and X1 because they are different variables. Like I said at the start, maybe they represent the radius of one atom and the radius of another atom, and if they're two different numbers, they wouldn't cancel. That's why we're using the 1 and the 2 subscripts to denote two different variables there. Notice also that I didn't bother to write multiplying this side by X1 and dividing by X1. I see a lot of students taking a lot of time writing those things out explicitly. If you're in the habit of doing that, try to gain some confidence, try to do it where you don't write that all the time, but yet see that if it's in the numerator here, it's going to come over as a denominator. If it's in the denominator here, it's going to go up to the other side of the equal sign as the numerator, because you'd be multiplying both sides by x1 over y1, so that you again become a more efficient problem solver, which will also make you enjoy problem solving more. If it takes you less time to do it, and you can get through more problems and get more problems correct, you start enjoying it a lot more. So lots of benefits to looking for ways to improve problem solving skills. Next one down, again, trying to solve for Z2, but notice now Z2 is already in the numerator, so we don't need to start off by multiplying anything. We just need to get rid of the 7, the R, the A, and the K. So one of the things we'd want to do is multiply both sides by AK. Now here I am writing it explicitly, but in my mind is just kind of screaming, oh, just go ahead and cross multiply by AK. And then we would divide both sides by 7R. So we would end up multiplying by A times K. That would get multiplied by X1, Y1. Z1 is still down in the denominator, and then we would take the 7 and the R into the denominator on the other side, because we're essentially dividing both sides by 7R, and we're doing that so that the 7R cancels. And all of that would equal Z2. So this then would be the answer. It doesn't matter what order you wrote the X and the Y and the A and the K in, it's all multiplication up there. So if we had 4 times 3 times 7 times 8, that's exactly the same thing as 8 times 3 times 7 times 4. There's some word for that. My mom was a math teacher. She probably would be disappointed that I don't remember. It may be the commutative property or something like that. All I know is that when you multiply two numbers together, it doesn't matter what order you write them in. So 4 times 2 is the same thing as 2 times. 4 times 2 is the same thing as 2 times 4. So if you had these in a different order, perfectly correct. If you had those in a different order, perfectly correct. You do need to have them, though, different in the numerator from the denominator. You shouldn't have a Z up in the numerator or R up in the numerator. Last one down here, very abstract, but again, illustrating the point that while we started with numbers, whatever we do with numbers, we can do with symbols, even if the symbols themselves don't look terribly mathematic. We want to isolate Z2. So the first thing we're going to do is multiply both sides by Z2. So we'd get percentage times $ over ampersand. The Z2 is going to come up over because we're essentially multiplying both sides by Z2. So we'd have that's equal to delta times hashtag Z2 divided by @ Now we want to isolate the Z2. That means we need to multiply both sides by @ So the @ is essentially coming across, canceling in the process. The delta and the hashtag would go down into the denominator. So when we do all that, we have @ coming across, percentage, $ over the ampersand, the delta, and the hashtag. All of that is equal to Z2. So hopefully you got to that point and that makes sense. And again, if it doesn't, that's why we're here. Review it, go back, maybe plug in numbers, just say 7 times 3 over 4 times 6 is equal to 5 times 8 over 19. And let's make 6 a Z here because we still need a variable, right? And then say, what would I do with that? So let me clean that up a little bit. 7 times 3 over 4 times Z is equal to 5 times 8 over 19. How would I handle that? Sorry, I don't have a ton of room on my desk here, so I'm at home trying to do this the best I can in my living room, like everybody else during COVID period, trying to make the best out of what we've got. So here we would just multiply by Z2. 19 comes across, 5 times 8 comes down, so we'd end up with 7 times 3 times 19 over 4 times 5 times 8 is equal to Z2, and then you could calculate that value, take out a calculator and get the value for Z2. So whatever you would do numerically, we do symbolically. Okay. So I hope that helps. Again, if there's questions, please don't hesitate to contact me, mark.vitha@drake.edu, and I hope you have a good rest of your day.